Good afternoon, everyone. Thank you all for joining today's session. This is going to be a Control M SaaS demo presentation. And before we get started, just a quick introduction on myself. My name is Yivar Kitabi. I am a workload automations consultant at VPMA, specializing in Control M and all of its different features, functionalities, utilities, and plugins. So happy to be here and looking forward to going through this demo presentation with you all. For today's agenda, we have a set of slides that we're going to go over covering an overview of the Control M SaaS application, its standard architecture, and some of its core features and functionalities. And after we're done with those set of slides, we'll transition on over to my Control M SaaS demo environment to see some of those features, functionalities, and utilities in action. Now, as you may already know, Control-M SaaS is a cloud-based workflow orchestration platform that simplifies, automates, and manages complex data pipelines and application workflows across hybrid, multi-cloud, and even mainframe environments. With Control-M, organizations can bring all of their operational processes such as batch jobs, file transfers, database workflows, and even other application integrations and more into a one single unified view. From an architectural perspective, Control-M SaaS is delivered as a dedicated tenant hosted and managed by BMC in the AWS cloud. And this SaaS tenant provides a centralized control plane, including the web client, automation API, scheduling engine, security, and governance capabilities. Workloads themselves execute on the Control-M agents that are installed on the customer managed servers. These agents communicate securely with the SaaS tenant and allow Control-M to orchestrate jobs where the data and applications actually live. On top of these agents, organizations can install supported plugins to enable native integrations with other enterprise applications, databases, cloud services, APIs, allowing workflows to be orchestrated end to end without having to rely on custom code or scripting. Control-M SaaS offers multiple tenant types to align with how organizations typically separate production, non-production, and sandbox environments. Production tenants are intended for business critical workloads. This is where enterprise batch, file transfers, data pipelines, and application workflows run in production. And we have non production tenants, which are used for development, integration, and any pre production testing. Functionality is the same as production, but with different support and SLA characteristics. And finally, we have our sandbox tenants, which are designed for learning, experimentation, and early testing. For production tenants, Control-M SaaS provides enterprise-grade availability and support with a 99.95% availability SLA designed for mission-critical scheduling and orchestration. Your production tenant also comes with 24/7 support and full incident severity coverage, including SEV1s and SEV1A, ensuring critical issues are handled with the highest priority. This ensures production workloads are backed by the reliability, support, and escalation models expected for core business operations. Now let's talk about the value organizations get from moving to Control-M SaaS. This isn't just about running Control-M in the cloud, it's about reducing operational overhead while increasing security, scalability, and speed. Control-M SaaS reduces costs by eliminating infrastructure management and upgrade efforts. There are no server maintenance, no platform upgrades to plan for, and less operational overhead, which directly improves the total cost of ownership of the application. From a security and compliance standpoint, BMC manages the SaaS platform, including availability, vulnerability management, and even compliance requirements. At the same time, customers can retain control through role-based access and site standards. Now, moving on to scalability, Control-M SaaS scales on demand without requiring customers to manage operating systems, databases, or licensing. As workload grows or new use cases are added, the platform scales with minimal administrative efforts. And with SaaS, teams can onboard faster, deliver value sooner. Accessing the latest integrations and plugins and innovations means less time setting up infrastructure and more time automating business processes. And finally, Control-M SaaS supports sustainability goals by reducing on-prem infrastructure, lowering energy consumption, and aligning with broader green IT and ESG initiatives. You'll see all of these pillars reflected as we go through this demo, from how quickly workflows are built to how they're secured, monitored, and scaled. Out of the box, Control M SaaS tenants come with a wide range of built in capabilities designed to provide visibility, governance, and operational control across all workflows. For example, we have SLA management, which allows teams to monitor workflows as business services, not just individual jobs, tracking whether critical processes complete on time and identifying risks early. We also have role based permissions, which enable clear user segregation, ensuring teams only have access to the jobs, folders, and actions relevant to their responsibilities, improving both security and governance in your organization. We have the automation API, which allows Control M to integrate into CI/CD pipelines and infrastructure as code workflows, enabling job definitions, updates, and deployments to be fully automated. And Control M also provides proactive alerting and centralized alert management, allowing teams to detect issues early, route notifications appropriately, and take automated actions before business impact occurs. These capabilities are available out of the box with every Control M SaaS tenant. And on top of our out of the box capabilities, Control M offers over 100 pre built plugins and integrations that can be installed on top of your Control M agents. These plugins extend Control M's native orchestration capabilities, allowing workflows to integrate directly with databases, cloud services, file transfer systems, APIs, and enterprise applications without relying on custom code or scripting. As you can see, we have a wide range of plugins available, such as Control M for Hadoop, Databricks, Snowflake, Kubernetes, and even databases. For example, with the Control M for Databases plugin, teams can create native database jobs directly within Control M. The plugin allows Control M to securely connect to a wide range of databases, such as Microsoft SQL Server, Oracle, Postgres, or any database that supports JDBC. This enables teams to run queries, scripts, or stored procedures as part of an end to end workflow, all orchestrated from a single platform, which is Control M SaaS. With that being said, let's navigate on over to our Control M SaaS demo environment and review some of these core features, functionalities, and utilities in real time. So in order to access your Control M SaaS environment, you should have received an email with your environment details, such as your username, your temporary password, and a link to your Control M SaaS environment. You can copy that link, paste it in your browser, and it should take you to a login page like this. Now, Control M SaaS supports a variety of authentication options. User accounts can be created and managed locally within the Control M application itself, or integrated with enterprise identity providers using SAML 2.0. This includes support for platforms like Okta, Azure AD, and other major identity providers, allowing your organization to align Control M access with your existing security and authentication standards. So once you're at this login page, you want to enter your username. If you were provided a temporary password, you can enter that temporary password. And after you log in with that temp password, you'll be prompted to set a permanent password. Once that permanent password is set, you'll be able to log in directly to your Control M SaaS environment. Now, since this isn't my first time logging in, it's not going to put me through that process. But in your case, if it is your first time logging in with your temp pass, you will be instructed to set a permanent password. So I'm going to go ahead and log in here. And we give it a second to load. After you log in for the first time, you should see a welcome pop-up like this that gives you all of the steps you need to follow in order to have jobs and workflows up and running in your Control M SaaS environment. As you can see, we have 4 easy to follow steps here. The first 2 steps revolve around installing your Control M SaaS agents and the necessary plugins. And the last 2 steps revolve around creating your jobs and workflows, assigning the agents that we've installed on them so they run on those particular agents, and watching them come into the active environment and run according to the scheduling, runtime, and dependency criterias that we set. So in order to get started, we can click on the first box here, which is the agent setup, and this should take us directly to our environment's configuration manager. Now here, this is where we manage our Control M SaaS agents and some of our additional environment settings. So if we look onto this right-hand side, we have our system settings, which we can go through. We can modify our logins and enable SAML 2.0 and integrations with identity providers. We have our API tokens, the different users in our environment, the different roles in our environments with the different permissions, our run as users, and our centralized connection profiles. Now, in order to install agents, we can click on this agent box in the middle here. This will take us to our agents list. Here we can see all of the different agents that are installed on our different hosts that are pointing to our Control M SaaS demo environment. We can see the agent's name, the connection status, whether they're available, unavailable, or disabled. We can see the status messages, if any, the Control M server, the tag, the host account, and even if those agents are part of a particular host group or not. And host groups in Control M SaaS are essentially a cluster of agents that act as another layer of high availability. So let's say you have a particular job scheduled to run on a host group. If agent one is unavailable in that host group, then the job will attempt to run on the second agent that is within that cluster of agents or the host group. So in order to add a new agent to our Control M SaaS environment, we can click on this Add Agent button. And from here, we can click on Install Agent. You'll get this right-hand panel, which shows you all of the different operating systems that you can install Control M agents on. You can see at the very top, we have AIX, Alma Linux, Amazon Linux, Debian, IBM, Oracle Linux, Red Hat, SUSE, Ubuntu, Windows, and even in order to install plugins, we want to click on the Install Plugin button, and it'll give you this right-hand panel pop-up similar to what we saw for the agent installations. Here we can see all of the different plugins that are available for us out of the box. Control M SaaS includes over 100 pre-built plugins and integrations that are available for us to use, and BMC continuously reinvests in R&D and integrations development, regularly delivering new and enhanced integrations to support modern, enterprise, and emerging technologies. This allows your organization to automate and manage workflows across your entire technology stack without necessarily relying on custom scripting. So as you can see here, we have a wide range of plugins that are available for us to use. We have a plugin for Jira, AWS. Going a little further down, we can see we have Azure DevOps, Databricks, Data Factory, Boomi Atmosphere, our databases, which we'll use as an example a little bit later, Databricks, Datadog, pretty much any application, almost any application that you can think of, we more than likely have an integration or a plugin for it, Docker Kubernetes. Now, as you navigate the different operating systems, on this right-hand side, you can see the full agent installation steps. So there are a couple of different ways we can install Control M SaaS agents on these operating systems. One, we have the standard install, which includes downloading the installation files, copying your agent token, and running the installation yourself, and using the agent token to connect your agent installation to your Control M SaaS environment. Aside from the standard installation, you also have the automated installation, which allows you to use the automation API to automatically install the Control M agent on your target host. Now, a prerequisite to this, you need to make sure you have the automation API CLI installed first on your target host so that you're able to run the automated installation commands. Now that our Control M agents are installed and populated on our agents list in our configurations page, we can run operating system level commands directly on the host where the agents reside using Control M jobs. These agents can also run jobs on other applications using plugins, and Control M has a wide range of plugins you can use, which allows you to orchestrate workloads across a broad range of applications and technologies. So let's take a look at some of the plugins that are available. To do so, we want to go back to the homepage of our configurations tab. And from here within the agents box, you'll notice there is a plugins button. Now, in a rare case where native integration is not yet available directly from BMC, Control M provides the application integrator, which enables teams to build custom plugins and integrations using APIs. and that can be accessed in the Control M Applications tab. Here we can see the application integrator itself. So between the application integrator and all of the different plugins that are available, BMC ensures extensibility and flexibility, allowing Control M to integrate with virtually any application or service. For today's demonstration, we're primarily going to focus on the databases, managed file transfer, and web services plugin. So in our plugins list, we can go down until we find the databases plugin, or we can also use the search here. After we found the plugin that we're trying to install, we can simply click on it. And on this right-hand side, again, similar to the agent installation steps, we have both the standard installation and automated installation available. Once you successfully install your plugins, you can now move on to creating your centralized connection profiles. To do so, you can click on this orange dropdown, and from here we can click on Centralized Connection Profiles. Centralized connection profiles define how Control-M securely connects to external systems and applications such as databases, cloud services, file transfer endpoints, and even APIs. These connection profiles store details like host names, file transfer endpoints, file transfer types such as FTP, FTPS, SFTP, S3 buckets, ports, credentials, tokens, authentication methods. Instead of hard coding these sensitive connection details inside every job, with centralized connection profiles, we define them once and reuse them across multiple jobs in our environment. This makes the environment more secure, easier to manage, and much easier to change. So if something changes like a password rotation or a endpoint update, you update the connection profile once and every job using it automatically inherits that change. So for example, we just installed the Control M for Databases plugin on one of our agents. Now we need to define connection profiles to connect to our database through the plugin that we've just installed. So to do so, we can click on this Add Connection Profile button, and from here we can select the plugin that we want to create the connection profile for. So in this case, I'll select Databases, and we get this right-hand panel pop-up. Now I already have a database's centralized connection profile, so we're just going to use that as our example. When creating your centralized connection profiles, there are three main tabs that can be filled out. In the general tab, we have our connection profile name and description, and right below it, we need to select our database type. So here I've set Postgres as that is the type of database that I am trying to connect to, but you can see all of the different options that are available. We have Oracle, MS SQL, DB2, Sybase, Postgres, SAP ASC, or any database that supports JDBC. Below that, we can select our database version depending on our database type. And next, we have our database connection parameters. Here we need to put in our host name, the port number, database name, and our database credentials. Again, this depends on the database type that you are trying to connect to. Some of these options may be a little bit different if you, for example, select the MS SQL database type. And we also have the advanced connection configuration. Here you can modify the advanced configurations of the connection profile, such as maximum concurrent connections, number of connection retries, connection retry timeout, and the connection idle time duration. Once you've filled all of your connection profile details in both the general and the database connection parameters tab, you can test your connection profile against the host where you have your databases plugin installed. So here I'll run a quick test, and if there are any issues connecting to the database through your agent, then it'll let you know here, and if not, it'll just say the connection to the selected agent validated successfully. Now that we've installed our Control-M SaaS agents alongside the necessary plugins and created our connection profiles for the plugins that we've installed, we can now navigate over to the planning domain. The planning domain is where we create new jobs and modify existing jobs in our environment. So In order to get to the planning domain, we want to go back into the main Control M application, and that can be done using the little tiles icon on this top right hand side. From here, we can click on Control M. Now, once you're back into the main Control M application page, if you're not already within the planning domain, make sure you click on Planning on this top left hand bar, and it should take you to the same screen that I am in now. From here, in order to create new jobs or modify existing jobs in our environment, we want to create a new workspace. There are a couple of ways we can do that. We can click on this little orange drop down here, add new workspace. There's also a new workspace button here. And we can also click on this add workspace button to again create a new workspace. Before we can get into our new workspace, we need to define our workspace definitions. As you can see on this right hand side, it's asking me for a workspace name, and right below it, a description, change ID, and email notification. These three are optional, and right below it, we have our site standards. Site standards are an out-of-the-box feature that come with Control M SaaS. It allows your organization to define rules and standards that must be followed by end users as they're creating their jobs and workflows. Once you select your site standard, you can click on Create, and this is going to take you to your new blank workspace. Now, once you're in a blank workspace, you'll notice it comes with an empty folder inside it. Folders in Control M SaaS are essentially containers for our jobs and workflows. You can create multiple folders and add your jobs and workflows to them. Now that we've created our workspace, we can use it to either create new jobs and workflows in our environment. And we can do that by right-clicking on our folder. There's a Add Job drop-down. And from here, we can see all of the different job types that are available. And simply clicking on them will add them to our folder. And there's also a Add New Job button on this top left-hand side. This again gives us the same job palette drop-down. We can use it to either add new folders to this workspace in case maybe we want to have our new jobs in different folders. And of course, we have the different job types that are available. So we can simply click on them and drag them over to our folders in order to begin creating our new jobs and flows. We can also use these workspaces to modify existing jobs and workflows that are in our environment. And that's exactly what we are going to do today. So we have a set of demo jobs that are already created. We're going to see how we can load them into this workspace. We'll use them to review the different job definitions, and then we'll set dependencies between them so they run in a sequential order. And then finally, we'll bring them into the active environment and run them so we can use them to review the monitoring domain. So to get started, we can click on this load button on this top hand panel, and it'll give us a right hand pop-up with a list of all of the jobs and folders that currently exist in my Control M environment. On the right hand side, I can filter for any particular jobs or folders. And once I find the folders and jobs that I want to bring into my workspace to make modifications to, I can simply select it on this left hand side. And we can either select the entire folder or the particular jobs inside it. In my case, I'm going to select the entire folder, so it brings in the folder and all of the jobs inside it into my workspace. Once you have your jobs and folders selected, you can click on this load button, and you should see the existing folder load into your workspace. Now at this point, we are ready to review the jobs and definitions, make dependencies between them, and order them in and bring them into the active environment in order to watch them run. Before we get into all of that, I'm going to quickly remove the default folder and the test job that we created earlier. And to do so, we can simply right-click on our job, delete, and we can also delete the default folder as well. After you make changes to your workspace, you can always click on this rearrange button to further rearrange and organize your middle graphical view. Now that we have our demo folders and jobs loaded into our workspace, right off the bat, you'll notice all of these jobs come with different icons, and these different icons are representative of the different job types. For example, if I click on the first job in my folder, we can see that it is a web services job that does an API call. The second job is a databases job that runs an embedded query. The third job is an SLA job, and SLA jobs in Control M SaaS give us another layer of monitoring for our critical workflows. So we can set this job at the end of our workflow. We'll have another layer of monitoring available in the services tab. We can monitor the entire flow as opposed to individual jobs. We can set particular completion times. So we can say this particular workflow should be completed within 10 minutes of coming into the plan. And then we can set notifications and alerts for deviations and failures within this particular workflow. So, for example, if job failure on service path, we can send an email, we can rerun the job if jobs ran too long, if the service is late, if the service ended not okay. We have a wide range of different actions that we can take with our SLA jobs. Next, we have our file transfer job here, which transfers the file from two different endpoints. And finally, we have our OS job here, which runs a basic operating system command on one of my demo control M agents. We can see it's a simple sleep for 10 seconds command. Now, looking at the job definitions themselves, we have four main tabs here. We have our general, scheduling, prerequisite, and actions. The general tab is going to be the only tab that'll be different across all of the different job types. And that's because the general tab specifies exactly what that particular job does. So the parameters are going to be different in the general tab for each of the different job types. For example, with our OS job, we have to specify where it runs, which user it runs the operating system command, the type of execution that'll happen, whether it's a simple command, script, or an embedded script. So in this case, it's just command, and we can see the particular command that is being run on this host as this user here. Next, with our file transfer in the general tab, we can see again the host. We can see the different file transfer endpoints that are selected. We can see our actual file transfer definition, so from which source it is picking it up with the path and the file name, and the destination that the file will be dropped into. And clicking on the advanced button, we can see all of the different file transfer advanced settings that we can set on our file transfer jobs. We have different source actions, destination actions, different options if a file with the exact name already exists on the destination. We can run FTP pre and post commands. We can rebuild the destination file name after the file has been transferred. So we have a wide range of options available with all of the different job types. Of course, looking back at our SLA job here, we can see our SLA management job definition. So we have a service name. This service name is what's going to show in the services tab after this SLA job comes into the active environment. We have the complete in parameter that is filled out for 10 minutes, which basically tells us that this particular flow needs to complete within 10 minutes or it'll be considered late. And here you have the remaining SLA job definition. So we can add additional service actions, kind of like we reviewed earlier for if job fails on service path, if the service is late, for example, we can set different notifications and alerts and different actions that we can take according to what is happening with that particular flow in real time. Next, we have our database job here. We can see in the general tab for our database job, we need to specify the host that this particular job runs on that has access and connectivity to the database that we are connecting to. We have our connection profile selected here, which is the connection profile we built earlier, which contains our database details and login credentials. And finally, we selected the execution type here. So we determine exactly what this database job does. And you can see we have a few different options available. We can run stored procedures, SQL scripts, or embedded queries. And finally, we have our web services job, which does an API call. So as you can see, the general definitions tab is going to be different for all of these different job types. But if we navigate over to scheduling prerequisites and actions, those are always going to be the same between the different jobs. So clicking on the scheduling tab, for example, on our web services job, by default, it is going to be set to an everyday schedule, meaning the job will be scheduled to run every single day, 7 days a week. But we have the option to change the scheduling definitions here. So we can click on this drop down and you can see all of the different options. So for example, we have none, which will make the job ad hoc, manual order. It will not run or come into the active environment unless a user manually brings it in and runs it. We have specific dates if we want this job to run on any particular dates. We can use parent schedule if we want this particular job to inherit its scheduling criteria from its parent smart folder. And we do have the ability to set scheduling criteria at a folder level. That way we don't have to set scheduling definitions on all of the jobs inside it. We can have all of the jobs just inherit the schedule from its parent folder. So that capability is definitely there. And finally, for anything more complex, with any other complex scheduling criteria, such as scheduling a job for the first Monday of the month or last Tuesday of the month, or again, anything more complex, such as running a job every 2 weeks, you can use the Advanced tab to accomplish that. And we can click on this Edit Settings here to see all of the advanced scheduling criterias that we can set. We can go with start of the week if we're looking for the first Monday. We can go with end of the month. We can set additional calendars for the job or folders to adhere by, and we can also set exclusions here. Finally, in the scheduling tab, we have our time settings. So here we can specify a particular timing range from when to when this particular job can run. So we can set a from start time and to end time. And we also have our rerun settings, which allows us to set the job to cyclic, which dictates the cadence of the job in the active environment, right? It allows the job to run multiple times in a day. And that could be according to a normal rerun interval of every 5 minutes, 10 minutes, every 2 hours, 3 hours, or whatever interval that you specify. When we enable this option, it'll also give us a few different interval settings, so we can use an interval sequence. So let's say we want the first rerun to be after 5 minutes, the second rerun after 15. We can use the interval sequence to accomplish a scenario like that, and we can even set specific times for the rerun. So we can say the first rerun should be at 10:15, and the second rerun should be at 12:45. Now going over to the prerequisites tab here, and in the prerequisites tab, we can set prerequisites for our jobs and folders. One, we can set required user confirmation. This will make it so the particular job will have to be confirmed once it comes into the active environment in order for it to run. And we have our lock resources and resource pools. These two options give us the ability to limit the total number of jobs running in our active environment. These are logical resources, and we can also use these to prevent simultaneous executions of two critical jobs. So let's say we have two jobs that take a lot of resources and cannot run simultaneously on the same host. We can use lock resources to prevent these two jobs from executing simultaneously. And finally, we have the Actions tab. Here we can see all of the post-processing that happens with our job. Here we can see the outgoing dependencies, notifications before job completions. We have our if actions, notifications after job completions, and we can even capture from jobs output. Now, one of the most important features here is the if action. If action allows us to take particular actions automatically when different scenarios happen. So we can click on this little plus icon here to see exactly how it works. So for example, if the job ended not okay, we can set it to notify. We can select our destination, whether we want an alert or mail or a job log. And also we can see all of the different actions that we can take automatically. So we can set the job to okay. We can set it to not okay. We can rerun the job. If the job is cyclic, we can stop the cyclic run so it doesn't fail over and over again. We can set a particular variable. We can run jobs in case of specific statuses and outcomes. We can handle output, and we can even add or delete conditions to trigger other jobs in our environment. And here we can look at the different ifs that are available as well. So if job ended not okay, if the job just ended with any status, if the job ends with a particular completion status, and we see this used all the time with file transfers of other customers. For example, we know that file transfer jobs fail with a status code of 7 every time there is no files found. So you can configure an if action to take any particular action that is needed in case no file is found. We can either just rerun the job so it looks for a file again, or we can set the job to an okay status since it's not technically a real failure. So we have a lot of different options and features available within the if actions tab here. We can go with number of executions, number of reruns, if the output cannot be found, meaning the job couldn't execute on the agent, if the job has not been submitted yet, or even the job's number of failures. So let's say the job is allowed to fail up to 3 times, and then after the third rerun, we would want the cyclic run to stop. So we can accomplish something like that by selecting job's number of failures, setting it to equal 4 or 3, and for the action, we can set stop cyclic run. So now that we've went over the different job definitions, let's create dependencies between these jobs so when they come into the active environment, they run in a sequential flow. So going back to the very first job in our folder, we can simply click on this little blue arrow and connect it to the next job in our flow, which is our database job. Once you make that connection, you should see a line connecting the two jobs. The prerequisites and actions tab for both of these jobs should be filled automatically. And now the database jobs runs only after the successful completion of the API web services job. Next, let's connect our database job to our file transfer job. Remember, our SLA job needs to be at the very end of our flow. So we are going to connect this to the very last job of our workflow. So let's go ahead and click on this blue arrow. We're going to connect it to our file transfer job. And whenever you make funky connections like this, you can click on this rearrange button to rearrange your workspace to give you a better middle graphical view. So now we can see all of the jobs that are connected on this left-hand side and all of the jobs without dependencies on this right-hand side. Next, we are going to connect our file transfer job to our OS job. Do another rearrange. And finally, we're going to connect our OS job, which is the last job in our flow, to our SLA management job. Do another rearrange. And now our workflow is created. It is set to run sequentially after the successful completion of the previous job behind it. Now that we've configured our jobs, we're ready to check them in order to save and submit our changes to the Control M database and bring the jobs into the active environment to allow them to run. In order to do that, we can select our folder with all of the jobs inside it. We can check in. Once our check-in is done, then we can click on this Run button on this top-hand panel, select Run Workspace. Here we can have hold selected, so it'll bring in the folder and the jobs inside it with a hold to give us more control on the release of these jobs and folders. With all of this set, we can click on Run. And now we're ready to migrate over to the monitoring domain. So there are a few different ways we can monitor our jobs and folders in Control M SaaS. One of the most common ways is using the viewpoints in the monitoring domain here. So you want to click on monitoring to navigate over to the monitoring tab. Before you can get a view into the active environment, you need to select a viewpoint. A viewpoint is a customized view into the active environment. So we have a bunch of default viewpoints that come with your Control M SaaS tenant, like all active jobs, all jobs, jobs grouped by status, grouped by folder, grouped by application, grouped by sub-application, and more. You can either use these viewpoints as is, or you can click on them and open them with a custom filter. So let's say on a particular day, you only want to see jobs that are in a failed status or jobs that belong to your particular application team, or maybe you only want to see specific job types such as file transfer jobs in your viewpoint or database jobs or basic OS jobs. You can set those customizations and filters using the Open with Custom Filter option here. So you can see all of the different attributes that you can set for your viewpoint filterings. We can go by application, host, different statuses, and so on. So in this case, I'm just going to open an all active jobs. We want to see all of the jobs that are loaded into our plan for the day, including the folder and the jobs that we just ordered in. So I'm going to go ahead and click on this all active jobs viewpoint, click on open. And now we have an all active jobs viewpoint showing us all of the active jobs in our environment. We can see we have a demo failed job here that is in a not okay status. We have our VPMA demo folder that we ordered in earlier to bring into the active environment. And if you recall, we set a hold on that order. So all of the jobs inside it came with this little lock icon indicating that we need to free it in order for this folder and the jobs inside it to run according to its schedule. So we're going to go ahead and free this folder here by clicking release. And as you can see, the very first job in this particular flow is in this pink status. Now, this is because of the manual user confirmation option that we enabled on this job. It's another layer of protection, ensuring that the job does not run without a manual user confirmation. You can see we have this setting enabled on our API call job, as well as the file transfer job that is a little bit lower in the flow. So I'm going to go ahead and confirm both of these jobs. It'll allow this flow to begin to kick off according to the dependency criteria and scheduling and runtime criteria that we've set. So I'm going to go ahead and confirm the file transfer. So when the time comes and the dependencies are met, the job is allowed to run. And finally, we are going to also confirm this API call job, which is the start of our flow. And once this is confirmed, the entire flow should kick off right away. And as we can see, the jobs here start executing. So let's go through everything that we see here. So we have a 3-panel view similar to what we have in the planning domain. On this left-hand side, we have a tree view of every job or folder that is loaded within our viewpoint. We have our middle graphical view, which shows all of our jobs and folders in a graphical display with all of their dependencies. And on the right-hand panel, we have the specific job properties. So when I select the Control M server in my tree view on this left-hand side, I can see the total number of jobs that are loaded into the plan for the day, as well as folders and subfolders, and we can see the different statuses on all of them. So we can see in total, we have 5 jobs that ended okay that are in this green ended okay status. We have 2 jobs ended with failures, 0 jobs waiting for manual user confirmation, and we have 1 job in this executing status. And you can see the different statuses that are available in Control M that you may see as you create and run your jobs and workflows. We have waiting for resources, which are the logical resources that we can set on our jobs. We have waiting for event, if a job is waiting for a particular dependency or runtime criteria to be met. So all of this is available as you click on the Control M server and the different applications and sub applications on this left hand tree view. Now, as you get more detailed and you start selecting your jobs and folders, the right-hand panel changes a little bit. So now we can see the specific job summaries that were loaded into the plan. We can see what they actually do, and we can see some additional run information as well, such as the status, the start time, end time, number of runs, and even the unique run ID. We can go into the job settings tab. This will show us the job definitions that were set within the planning domain. So we can see the general tab of the job and what it does. We have the scheduling tab, which shows us the scheduling parameters of this particular job. We have the prerequisites and our actions. We have our web services tab. We have our logs, which shows us a lifeline of this job since it came into the active environment. So we can see exactly when it was loaded in, when it was freed, when it was confirmed, which connection profile name it used, and at what time it ended okay and began its post-processing. We also have the outputs of our jobs here, so we can see the output of the particular execution that happened. So this is our API call. We can see the response. We have our database jobs. We can see the output from our embedded query. We have our file transfer output, which shows us the result of the file transfer that happened. And next to the output tab, we have our statistics. Statistics give us statistics based on the last runs of the job. If there have been no previous runs, it'll by default say 5 minutes. But if the job has ran before, it'll use those executions to give you an estimated start time, run time, and end time. So let's say you have a failure in your Control M environment that you'd like to troubleshoot and rerun. We can see we have a demo failed job here. We can go into the output to see exactly why it failed. And this particular failed job demo, it is failing because it is set to run a exit 101 command. And anything outside of a status 0 is going to produce a failure in Control M. So what we can do here, we can put this particular job on hold, click on edit. We can make modification to this instance of the job's command line. So we can say instead of exit 101, we wanted to run a exit 0 command. We can save. And once our changes are saved, we can release our hold and rerun the job. And now with the second rerun, we can see that the job ended okay. Again, we can check the logs to see exactly what happened during this period. So you'll be able to see that it was held by my user, changes were made to it, the hold was released, and the job was rerun. We can also check the output for the output of the execution. Now, another way we can monitor jobs is using services. So for this particular flow that we created, we did set up an SLA rule. We have an SLA job at the end of it that basically tells us this particular flow needs to complete within 10 minutes or it'll be considered late. Now, in order to monitor our SLA workflows, we can simply go into the services tab here. We can see the demo completion service that we created and added to the end of our flow. And we can kind of confirm that if we go back to our SLA job here, we can see the service name is demo completion, and it's supposed to complete within 10 minutes. If we go back to our service tab, we can see exactly that here. We can see that the demo completion service did in fact run and end on time. We can see the different statuses if there are any particular jobs still executing, waiting for event. We can see how many are waiting for a user confirmation, and finally, how many of those jobs within that critical workflow ended okay. We have our errors tab if there are any errors. We have our logs, which give us a log of everything that is happening in that particular SLA. And finally, we have our parameters tab. And when we click on that SLA, it'll open up a viewpoint showing us only that particular flow and all of the jobs inside it. With that being said, that pretty much brings us to the end of this demo. There are still tons of features and functionalities. We can probably talk about Control M SaaS for another 3 hours, but I think we went over the main topics here. So we went over installing our Control M agents and the necessary plugins. Then we went over the planning domain, which is where we create new jobs, folders, and structures, and make modifications to existing jobs and folders in our environment. And finally, we got to see those jobs run in the active environment within the monitoring domain with customized viewpoints and even using services and SLA management to view more critical workflows in our Control M environment. So, with that being said, I hope you guys found this demo training valuable. If you have any questions, please reach out to me and I'd be happy to go over any particular topics in more detail. Thank you.